Cool. We're all set.
Well, I've been relying on the QQ plots or the histograms to make my, whatever that's called. But it sounds like they're bringing back the box plots. And so one of the things I tried to get the directions from, because I had not done those for like ages. And in the answer video, if you have any problems or something, he does give the directions for that. So I'm just putting that out there. If you don't have those things.
But actually, the problem I've had with is finding the margin of error with the number of freedom or whatever. That's been the hardest thing for me to do. I keep getting it wrong, and I don't know what I'm doing wrong.
The formula I thought was that you took the, let's see, the upper confidence level, subtract the lower confidence level, and then divided by 2. But I got one time on the, I think it was the homework, I got it right. And on the prep test or the other one, I got it wrong. So I don't know if that's right or not.
Yeah, I don't know what I'm doing wrong, but like I keep getting it wrong, and I'm like, I don't know what's going on. But like you're supposed to use the degrees of freedom and the whatever else it's called. What is it called? I can't remember what it's called right now.
Sounds like a good question for the exam review on Wednesday.
Good point.
Yeah. That'd be good. I'm starting my little list. If it's that kind of a format, I hope it is at least.
What lessons are this exam covering?
I think from 7 to this last one, 12 or 13 rather.
So it won't cover 14?
I don't know for sure.
Oh, okay.
I don't know if it will cover 14 or not. I just know that it will for sure cover those.
That's what we're on this week, right? Is lesson 14?
It's 14,
yeah.
Mm-hmm.
Okay, good. Are you guys ready to do the quiz?
And 14.
Yep.
I've got mine open.
I'm getting there.
Okay. I got stuck on the soccer shoe one. So dumb. Hey, how do you guys figure out the p-value? I got that wrong for lesson 12 and 13. Both questions that I got wrong on the quiz were the p-value. And I can't figure out what I'm doing wrong.
That depends what it's on, if it's greater than, less than, or not equal to in the thing.
Okay.
And then it's just really choosing to write the correct one.
Right.
Because you're right, I got like one of them wrong, and then the rest of them I got right, but I don't know. Yeah. I don't know exactly how to. I'm having a hard time differentiating like what it wants me to do greater than, less than, or not.
Yes, me too. The way that it's worded is very confusing, and so I'm having a hard time figuring it out.
Yeah. Yeah, I've been having a hard time with that too. But it's really just that and the margin of error. That's the only thing I'm having trouble with. But it's enough that it's giving me 80s on the quizzes, and I don't like that.
Oh, I'd be happy with 80s. That's when I don't do the quiz again. If I got right. I'm just ready to be done.
Yeah, same.
So I'm all set for question 3. We all set?
Yeah.
Okay.
Who wants to read it?
Well, I'll take question 3 since I think I know that one. Here we go. In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. That's true.
True. I got it.
Yep.
And then number 4, what requirements need to be checked before performing a ANOVA hypothesis test? And I put B and C.
B and C, yeah. So I got.
Yeah. And then number 5, to check if each group is normally distributed, do the following. Construct a QQ plot for each group.
Mm-hmm.
I put QQ.
Number 6, we assume the variance in each group is the same if the following happens. I put B. The largest variance is less than 4 times the smallest variance.
Mm-hmm.
And isn't it less than or equal to? But that wasn't an option. So,
Mm-hmm.
that close enough? Yes.
Mm-hmm. Yep.
All right, and then this is where I started to get stuck. So for number 7, it says an ANOVA hypothesis test is equivalent to conducting independent 2 sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there if there are 4? There's 4, right?
Yeah.
Okay.
I think I worked that out to be 6.
6?
Yeah, because you're going to match 1 with 2, 1 with 3, and 1 with 4. Then you're going to match 2's already been matched to 1. It doesn't match to itself, so then you'll have 2 with 3 and 2 with 4.
Oh,
Then 3
I
won't,
see.
yeah, and so then 3 won't match to, it's already been matched to 1 and 2. It doesn't match to itself, so then you'll have the pair that's 3, 4,
Okay.
and then that's it. Wait, how many was that? I think
That's 6.
yeah.
Was that 5 or 6?
5
That
or
was 5.
It's 5. Okay, so we have 1, 1, 1. No. 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. That's 6.
That's
Yeah.
6.
Yeah.
And then I stopped here because it was time to start. So, and I didn't understand it.
Please be the right one.
Okay.
I don't know where I put my like calculation Excel spreadsheet, so I'm like guessing. Nope, that's the wrong one. So it's this one. But it sure takes its time to open.
Okay, that's the question. The question is, what is the smallest variance for the 6 groups? Okay. Well, if I could get back to that, I would. Smallest variance. 27. So, to me, it looks like 27.208. Where variable number 3 is the smallest variance.
How did you find this?
So I just went to the, when you open the quantitative inference procedures and you click on the ANOVA tab, and then I just put the information that they gave us in the file into the variable 1, 2, 3, 4, 5, and 6 slots. And when I did that, it pops out in the descriptive statistics box on the right. It has a column for variance, and it gives the variance for each of the variables.
Okay, so I want to do it real quick. So section A goes in the first variable column, right?
Yeah.
Section B. Okay.
Oops.
I need another computer screen. I can't do that.
What happened? What did I do? Oh, I don't know what happened here. Does that mean that socks is a variable as well?
Yeah, because it asks a few questions later to take out the socks variable, so I'm assuming they want us to have it in right now.
Okay.
Yeah. Plus, it says 6 groups. So you'd have
Good
the socks.
This is so slow. So sorry.
Oh,
My computer doesn't like all of these tabs open. It keeps freezing my Excel.
Yeah, mine too.
Okay, so socks is variable 6.
Correct.
Last one.
okay. And then we have the smallest variance of 20. I got 23.74 is what we ended up with.
No, I don't have one that's 23. Maybe I pasted one wrong.
I don't have one that's 23 either. What's the question here? What's the minimum smallest variance for the group? 6 groups.
Right.
So my smallest one is 27.208.
That's what I have as well.
What did I do wrong?
Did you
That
get
says
all of the
variable
numbers?
one. Let me try my variable 1 again. Because I want to make sure that I'm doing this correct.
Yeah. It's hard to copy and paste these things because they're all in the same row. I wish they were separated so that you don't
Right.
accidentally get
So much
one from a
easier.
different thing.
One way to check it is the number for each column. If you want to compare that.
Okay, now I got it right. I missed a thing.
Cool.
Okay, yeah, so
Okay.
27.208. Okay.
Okay, so what's the maximum? Mine is 53.158.
Yes.
Yes, that's my math method.
One more time, Kristen.
53.158.
Thanks. Double checking.
For equal variances by previous data. Four times the smallest variance. Less than or equal to 4 times the smallest variance.
So in my understanding, you would take the smallest variance that we got of 27.208 or whatever it is, and you would multiply that times 4 and see if it's more than the highest variance.
Oh.
But in this case, not, which means they're equal, or that they're considered equal.
So they're not stratified.
False.
No, it satisfies it because we want them to be equal.
Oh, and it is equal because it's not 4 times
Right,
whatever.
right.
Okay, I can't remember how to do a QQ plot.
That's back to quantitative inference, and it's a tab down at the bottom. I'm sorry, quantitative something.
Oh, okay. I need to open up another thing.
Yeah, quantitative descriptive, let's see, what's it called? It's called quantitative descriptive statistics.
Got it. Okay.
Oh man. Well, I just did the first one and it is like far from normal looking.
It's important. What I forgot at first is to make sure that that they're in smallest to largest or largest to smallest.
Oh, yeah, you're so right. Totally forgot to do that. Let me try that again.
Wait, remind me what information needs to be pasted in this
So
column.
so when you go to the QQ plot, you can only enter one variable's information at a time. So you have to cut and paste, like you'll do all of column or variable 1 or A or whatever it says. Whatever.
Okay.
You'll put all those in there. And then Donna made a good point. We have to remember to sort from smallest to largest. Okay, that looks so much better.
What the variance has to be sorted smallest to largest?
No, hold on. Let me go back to it again. Okay, so you see column A where it says variable 1? You'll select all those numbers from variable 1, and then you'll paste them into the quantitative descriptive statistics Excel sheet in column A. And then sort it from smallest to largest, and that will give you your QQ plot.
Does not want me to paste.
Just make sure you're on the QQ plot tab.
Yeah, I am.
Okay.
I'm going to screen share what mine looks like really quick and see if you guys got the same thing. Application window, this one.
Yes, that's what mine looks like.
Awesome.
That's what mine looks like.
Cool.
Yay!
All right. I'm going to stop sharing now. Okay, so that's the first one looks normal. Now we have to do the rest of them.
This is terrible.
Okay.
I'm trying to find my notes. They went over this in one of the videos, and he went through all of these, but I'm trying to find it.
Approximately normal based on what you see on the QQ plot.
I would say true.
So yeah, so far I've done 3 of them, and the first 3 look normal.
I just found my notes. It says QQ plots, data equals normally distributed.
Yes, that's what I have too. Sorry.
Man, this doesn't want me to paste anything in there.
I'm gonna check them though. I can't find it now. There we go. That one's normal.
I did the last one and it looks normal too. I don't know if you've gotten to it yet, but
No, I haven't.
it's normal. I just figured I'd work my way back since you were working forward. So
Yeah.
that makes it true then? For each sample are approximately normal based on what you see on the QQ plot. Yes.
Yeah.
You perform an ANOVA test so that the p-value is remove the soft data.
Oh, I can't find the quiz now. Where is it? Nope, that's not it. There we go. Finally found it.
What is the p-value when you remove the socks? I got 0.309.
Yeah.
Yes, that's what I got also. Point.
Time, Kristen?
0.309.
Thank you.
Area to the right.
I think this is
To the right.
Yeah.
To the right. To the right. To the right.
Oh, we gotta do QQ plots again.
Nice. Oh, okay.
I don't want to.
Download, please.
Oh my goodness.
You think it's safe to close the stupid stock one now?
I'm going to.
So many things open. Yeah, it's all hot dogs and corn dogs. My least favorite food.
I like corn dogs and I don't like hot dogs, but now I'm not eating them anymore because I know what they're made out of and it freaks me out.
I like them all. I don't know what they're made out of, and I still like them.
Okay. So, what's this?
What are we supposed to be?
Hot dog.
So does that mean that there's going to be? I don't know what we're supposed to be putting in there.
For each of the 54, blah, blah, blah. Use this data file to answer the
Okay, let's examine.
calories first.
Okay, so we're supposed
Oh,
to.
so beef is
Calories.
1. So is that variable 1?
Yeah, because it's first.
Because what?
Because it's first.
Oh my God, they have beef and meat separated.
I know, I was just looking at that too. I was like, that's ridiculous.
Like, okay. Is that not meat or whatever?
You know, I think they have to, yeah, specify.
Okay. I got a little behind. We're on question 14, right?
Yes.
Yes.
And we decided on B as in boy.
Oh, crap.
I'm still working on it. I just got the very first QQ plot done for the beef calories.
I'm not even there yet.
I'm
so
not
you
even
guys
there
Have a minute.
Okay.
And let's see, the beef calories QQ plot looks normal.
Okay. We'll do the meat
Now
then.
let's see. Then we have meat and poultry. Somebody do meat, and I'll do poultry.
I'll do meat.
What do I need to do?
We're making QQ plots for the calories.
Did you guys already assign them all, though? Is what I mean?
Yeah, we're
Yeah.
I'll just sit right here.
You can just sit there and be moral support for us.
All right.
What I'm good at.
Looks normal.
Yeah, so does poultry. Poultry looks normal. So the assumptions. Wait, let's examine QQ plots and compare the variances. Okay, so I haven't put any of my information in to compare variances yet, though.
Okay.
Done that?
All of mine is in, so I can compare the variances. That's what I was doing.
Okay.
So are the variances equal? The lowest one is 508.566,
0.5.
and we times that by 4.
Yeah. And make
Yeah,
sure that
they're equal. Is that what you said? They're equal?
yeah.
Yeah. So does that make this A?
Yeah, that means the requirements have been met. If the variances are equal and all the data is normal, then it means the requirements have been met.
Okay, perfect.
4.5.
Three types of hot dogs.
So if it's bigger than the variance, than the biggest variance, that's equal still?
It has to
Yeah.
be,
4 times.
the lowest one has to be no more than 4 times the largest one.
Oh, then what am I? 4 times the largest one.
Right. And it's not. That would put it up at like 2.
Take the
Oh,
smallest
yeah, because
variance.
it's like 2004.
Yeah.
Okay,
Find the degree of freedom.
sorry.
51. My degree of freedom is not 51.
Okay, wait a minute. I'm behind because I just got everything put in there, so hold on a second.
My degree of freedom is 16.074.
Mine is very wrong. I did something bad here.
Oh, wait, just kidding. I was not looking at that. That's my F statistic. Just kidding. Mine is 53.
Well, my F statistic doesn't match what's listed here either.
Okay, run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51. That's what I got. And F is 16.074. Let me look and see.
What did we, I'm sorry, what did we just say for 14?
14 is A.
It's A, okay.
And a p-value of 0 is equivalent to 5. P-value is not, where's my, okay.
Or 2 and 51. Yeah, that's what I have.
I have all
No.
the, I match everything on 15 except the p-value. My p-value does not equal 0.
Is it 3.86?
Yeah. Oh, wait, I guess that's,
Oh, but it's negative. It's negative to the,
yeah. So that is 0, 0.
that is 0.
Yep. Okay, so what conclusion can you draw?
If the p-value is less than
We are
0.05,
rejecting
you reject the null.
And in this case, our null would be that all the numbers are equal. So we have sufficient evidence to say that they are not all equal.
Wait. Mine is not what your guys's is. And I have no idea why.
What number?
I have that my degree of freedom is 2 and 48.
Oh,
And my F, what's it called? F statistic is 16.79.
So you
a little.
What?
I said you must be missing like a value somewhere in your, like when you copied and pasted.
Ah, there we go.
Did it fix it?
Yes, it did. I was missing several numbers on variable 1. I didn't copy all the way down.
Oh,
So that fixed it. So much better. Okay, sorry.
but we have sufficient evidence to claim that all of them have the.
No. It was the
One,
null that, for the null, we're assuming that they're all equal. So if we're rejecting the null, then that means that one of them is not equal to the others. Which one of these is not like the other one? So in this case, the p-value is low. We're rejecting the null. So we have sufficient evidence to say that at least one of these hot dog types is not the same as the others.
Ah,
D. D is a dog for hot dog.
Right.
Okay.
did you say D?
Yeah.
What?
D is in donut.
Yes.
Okay. I was like, B's wrong.
Now we have to look at the sodium. And go like, oh my gosh, this is so tedious, right?
It is.
Setting this up it's a beat down.
Okay, now we got to do the Q plots.
Oh, dang it. And it's gonna get mad at me because it doesn't like when I put all the weird things in.
What's a weird thing?
Well, like for some reason, when I don't have it like all the way open, it doesn't let me like paste it in.
Oh.
It's really stupid. See, and then yeah, it makes a little mad sound.
My computer's not wanting to let me do anything.
Okay, let me see. I got the first, let me go back to it again. First QQ plot for sodium looks normal. Now I'm gonna do the second one.
I'm doing the third one right now.
Okay.
Sweet.
The third one does not look normal. It's all over.
Did you sort it smallest to largest?
Oh, sorry. No, I didn't. Let me fix that.
That's what I did earlier this evening. The second one looks normal too.
Mine is now giving me A to Z. How do I sort it? What?
Right click and go down to sort and then choose smallest to largest.
Sorry, I forgot to highlight it. Smallest to largest.
Yeah.
Yes.
Semi-normal. There's some above the line and some below the line, but not too far. Does that matter?
How much below? Is it on the tails or is it in the middle?
Such a fantastic question. It's not normal, according to my husband.
And it's
Hold on.
suggesting in the question that there's a problem with poultry. So that kind of indicates it too. Poultry's the third one.
Okay. I'm gonna copy and paste it just to look at it because I haven't seen a not normal one yet. So I actually just want to see this.
Me neither. But it looks, I mean, it looks semi-normal, like you said.
Oh yeah, that's
it's
not normal.
crazy, but I don't think it's normal.
Oh yeah, that's normal looking.
Yeah.
Okay, so we're gonna go with not normal on that one.
Okay, good.
Yeah, that doesn't look like the other ones either. So, okay. Here's the smallest variance and the largest is this. Okay, so if we're just looking at the variances are considered equal. So have the assumptions been met? I'm going to say no, they've not been met because they haven't come from a normally distributed population.
Right. So is that C? I think it's C.
It is not safe to assume, yeah, that we can assume the variances are equal. Yep, I would say C. Yeah, 17% gives you the answer, despite the possible problem with the QQ plot for poultry.
Yeah, it won't probably do that on our test.
So we won't be so lucky.
So the p-value I got is 0.179.
Yeah.
That's also what I got.
One more time. I'm just catching up with you guys. Go ahead.
0.179.
And what did we decide on question 16? I'm still reading through them.
C. C like Charlie.
Okay. Thank you.
What conclusion can you draw about the mean sodium levels of all three types of hot dogs?
gosh, let's get back to the thing. Okay. Well, I would say that the sodium levels are, we do not reject the null here because our p-value is greater than our level of significance.
Mm-hmm.
So since we don't reject the null, we have insufficient evidence to conclude that there's any difference, or to conclude that they're not equal. What's the choices here? Let's see.
We have sufficient evidence to claim all three have the same mean. We do not have sufficient evidence to reject the claim that all 3 hot dogs have the same mean sodium levels. We have sufficient evidence to claim that all 3 hot dog types have a different mean sodium level. We have sufficient evidence to claim that at least one of the hot dog types has a different mean.
I'm going with B. We do not have B as in boy. We do not have
the one that's not sufficient.
Yeah, we do not have sufficient evidence to reject the claim. So we cannot reject the null. And then the null is that all 3 hot dog types are the same. We can't reject that. So it's B. Yay, and that's the end.
What do you guys get for number 9? I think I messed something up here.
Number 9?
Yeah.
I have 53.158.
Okay, so what was number 8 then?
27.208.
27 point, well, I'm sorry?
27.
47?
No. 27.208.
Okay, and then what's number 10? I messed something up along the way here.
10 is true.
True, okay. Okay. So I just mixed those up. I missed one apparently. Okay.
We got 100.
We did.
Right.
Yay.
Yes.
I'll take it.
I love how like these tests, I feel like I do like so well because like I understand everything, and then as soon as I get to the homework test, I'm like, oh my gosh, why are you throwing curveballs at me that I don't understand?
I know. I feel the same as you. I get to the homework test and I'm like, really? Why do I feel like I've never seen this before?
Right? It's like, why do I feel like we didn't talk about this ever?
Right.
Oh my gosh.
Pretty much.
All right.
Good night, ladies. Thank you very much. I'll see you Wednesday. And good luck on the exam.
There you go. All right. Bye.
Bye.
Bye.